What is this? A pressure transmitter measures pressure and converts it into a standardized output signal, which can be an electrical, analog or digital, or pneumatic signal. In this case, the CI and the presence of pneumatic fittings suggest it's likely an I/P converter, meaning it takes an electrical current input signal and converts it to a pneumatic pressure output. How does it work? The working principle depends on the specific type of transmitter, but here's a general overview followed by details specific to the likely type in the image. General pressure transmitter working principle. 1. Sensing element. The core of the transmitter is a sensor that interacts with the pressure being measured. Common types include diaphragm, a flexible membrane that deflects under pressure. Borden tube, a curved tube that changes shape in response to pressure. Strain gauge. Electrical resistance changes with strain caused by pressure. Piezoelectric. Generates an electrical charge proportional to pressure. 2. Signal conditioning. The sensor's output is often weak and needs to be amplified and conditioned. This may involve temperature compensation, linearization, and filtering. 3. Conversion. The conditioned signal is converted into a standard output signal. This could be electrical, 4 to 20 milliamperes DC, common industrial standard. Voltage, 0-10 volts DC. Digital, HART, Fieldbus. Pneumatic, 3 to 15 psi, common in older systems. Specific to the IP converter in the image, likely. 1. Electrical input. An electrical current signal, typically 4 to 20 milliamperes, is applied to the device. 2. Electromechanical conversion. The current signal drives a mechanism, likely a coil and flapper/nozzle arrangement, that generates a proportional pneumatic pressure. 3. Pneumatic output. The resulting pneumatic pressure is the output signal, which is used to control a pneumatic actuator or valve. What is the work principle? Measurement. The sensor measures the pressure. Conversion. The measured pressure is converted into a proportional signal, electrical or pneumatic. Transmission. The signal is transmitted to a control system or display. Where is it used? Pressure transmitters are used in a wide range of industrial applications, including process control, monitoring and controlling pressure in pipelines, tanks, reactors, etc. in industries like oil and gas, chemical, pharmaceutical, and food and beverage. Automation. Providing feedback for automated control systems. HVAC. Monitoring and controlling pressure in heating, ventilation, and air conditioning systems. Water management. Monitoring water pressure in distribution systems. Aerospace. Measuring air pressure in aircraft systems. Specifically for I/P converters. I/P converters are typically used to interface electronic control systems with pneumatic actuators or valves. They are common in older plants or in hazardous areas where electronics need to be isolated. Types of pressure transmitters. Pressure transmitters can be classified by various factors. Sensing technology. As mentioned earlier, diaphragm, Borden tube, strain gauge, piezoelectric. Output signal, analog, 4 to 20 milliamperes, voltage. Digital, HART, Fieldbus, pneumatic. Pressure type, gauge. Measures pressure relative to atmospheric pressure. Absolute. Measures pressure relative to a vacuum. Differential. Measures the difference in pressure between 2 points. Application. General purpose, hazardous area, submersible, hygienic, etc. Based on the image, the specific type is likely an I/page, current-to-pressure converter, characterized by its electrical input and pneumatic output. The exact specifications and functionality would be found in the manufacturer's datasheet for that specific model. It's important to note, without more information about the specific model number, which may be on the other side or obscured, it's impossible to give a definitive answer about its exact functionality and specifications. The details above are based on the visual clues and general knowledge of pressure transmitters and I/P converters.